Interpreting rules of derivatives. On the AP exam, you must be able to use tabular data to find derivatives, in addition to calculating derivatives on your own. These problems are not incredibly difficult, but can be distracting due to extraneous information, or information that you don't necessarily need. Let's try an example to see this in action. The functions f and g are differentiable for all real numbers. Let h of x be equal to f of x times g of x. Calculate h prime of 1. It's important to decipher which information we will need from the table to calculate h prime of 1. The first thing to notice in the given information is that h of x is equal to the product of two functions. So in order to find its derivative, h prime of x, we're going to need to apply the product rule. So h prime of x is going to be f prime of x times g of x plus f of x times g prime of x. So you're setting up the product rule in its general form, and then we can substitute 1 in for our x values. So h prime of 1 is equal to f prime of 1 times g of 1 plus f of 1 times g prime of 1. The next step is to use the chart in order to substitute in the values of f prime of 1, g of 1, f of 1, and g prime of 1 into our product rule and then simplify. So we're going to have f prime of 1, which is 2, times g of 1, which is negative 2.5, plus f of 1 is 3 times g prime of 1 is 0. So 3 times 0 is 0, so we can ignore the product of the last two numbers. And 2 times negative 2.5 is negative 5. So h prime of 1 is equal to negative 5. Let's try another example. The functions f and g are differentiable for all real numbers. Let h of x be equal to x to the third minus f of x divided by g of x. Calculate h prime of negative 1. The first step is going to be to calculate the derivative of h of x, or h prime of x. First term is easy to differentiate. It's going to be 3x squared. But then we have to apply the quotient rule for the minus f of x divided by g of x. So we need to do 3x squared minus the bottom, g of x, times the derivative of the top, f prime of x, minus the top times the derivative of the bottom, or f of x times g prime of x, all divided by the bottom, g of x, quantity squared. Now we can substitute negative 1 in for all of our x values. So we have 3 times negative 1 squared minus this quotient, which is f prime of negative 1 times g of negative 1 minus f of negative 1 times g prime of negative 1, all divided by g of negative 1 squared. Next, evaluate and use the chart to substitute the values in of f prime of negative 1, g of negative 1, f of negative 1, and g prime of negative 1 into the quotient rule formula. So our first term is going to be 3 times negative 1 squared, or just 3, and then minus f prime of negative 1 was 1/2 times g of negative 1, which is 6, minus f of negative 1, which is negative 3, times g prime of negative 1, which is positive 2, all divided by g of negative 1, quantity squared. And now we can simplify. So we're going to have 3 minus 3 plus 6 divided by 36. So that's 3 minus 9/36, or 3 minus 1/4. 12/4 minus 1/4 gives us 11/4. Another type of question you may encounter on the AP exam involves tabular data and derivatives. So let's use the table to the right to estimate f prime of 2. Since we know that we are dealing with 2, we need to look for the 2 nearest points to that x value that you're looking for. So we have 1 and 91/100ths and 2 and 2/10ths, and 2 lies between those values, and we know the corresponding function values are 4 and 6/10ths and 5 and 8/10ths respectively. Since we do not know what f of x is, we can't write a function for f prime of x and substitute 2 into it. Instead, we can approximate f prime of 2 by calculating an average rate of change using the slope formula and these 2 points that are around 2. So f prime of 2 is approximately equal to 5 and 8/10ths minus 4 and 6/10ths, all divided by 2 and 2/10ths minus 1 and 91/100ths. And when we evaluate it, we will get that f prime of 2 is approximately equal to 4 and 138 thousandths.